purpose of this video is for you to be able to describe how a cloud becomes a star. This is what a star kind of starts as. It's a big cloud of interstellar material, mainly hydrogen. It's really cold and really big, much bigger than our solar system. And it's extremely low density. Now, within the cloud, there's a part of it that you can see here. There's just by chance, there's more particles. And the more particles there are, the more gravity that's got it, or is present there, and that's going to start pulling in and attracting other particles to it. So as these particles start to amass at a certain spot, this spot becomes pressurized, it becomes hot, dense, and its temperature goes up because of the gravity pulling it in, causing friction. And now, this is going to keep occurring, and you're going to form what is known as a protostar. And a protostar is something that is going to become a star because this star is going to be hot enough to be sustained fusion. And once fusion starts, the star will undergo some radical changes. In that, once fusion begins, and fusion is converting 4 hydrogen atoms into a single helium atom, and therefore releasing lots of energy. This energy will push out against the star and cause the star to stop collapsing, because now we've got an outward pressure coming out from the center, and that star counteracts gravity that is pulling the star inward. And when these two things balance out, we've got a full-fledged star. Now, the reason this became a star was because of its ability to sustain fusion. There are other clouds that really, not clouds, but other parts of the cloud that amass particles that don't get hot enough to sustain fusion. Jupiter is kind of a good example of that. Jupiter being this huge cloud of hydrogen, or not really, huge ball of hydrogen that's not really hot enough at its core to sustain hydrogen. Sustain fusing hydrogen. I think the Sun is about 10,000 degrees Kelvin, where Jupiter is about 3,000 degrees Kelvin. Now, stars spend most of their life cycles in this phase. It's called the main sequence, where their core is fusing hydrogen into helium, and the star is kind of at a status quo and maintaining equilibrium. And this can last a really short time or a really long time, depending on the mass of the star. Now, once the core runs out of hydrogen, fusion will stop, and these outward forces will go away. And now I've only got gravity pulling in and the pressure within the star, and that's going to cause the core to collapse. All right. Now I've blown this up just to make this picture a little easier to see. And as the core collapses, what's going to happen is the star's core is going to heat up again, and something's going to happen. Either the star is going to get hot enough to rekindle its fusion fires and go on to like the next stage of its life, or it could just kind of peter out and stop fusing. But we're going to follow the life sequence of stars where the fusion rekindles. So when the core collapses, and if it gets hot enough, it's going to start fusing helium in the center, and that's going to release more force outward. It's also going to release a lot of radiant energy, so that you're going to have fusion happening not only in the core but outside of the core. And this is going to have more of an outward force than before, because you have more fusion occurring. So you expanded the area, so you have more outward force, and this is going to cause the star to swell, and it's going to swell into what's known as a red giant. And red giants are enormous. The sun is theorized, when it becomes a red giant, it will engulf the Earth, and that the Earth will be on the literally on like the exterior of the sun's actual atmosphere. Now, red giants, once they're made, they follow a similar fate as the stars that gave birth to them, in that when there's fusion going on in the core, they're going to maintain their size, and they're going to keep radiating energy and just doing what stars do. Once fusion stops, this is for small to medium stars. This is like the sun. The sun's kind of a medium star in comparison. The core will once again collapse, and when it collapses, it's not going to get hot enough to fuse the elements that are in there. For a star like the sun, this is elements like carbon. It's going to stop at a carbon element or carbon fusion cycle, and it will cease to fuse elements. Therefore, there's no outward force, so it's going to collapse. And what happens is it expels its outer layers in the process, and in the center is what's left behind is a white dwarf. And these outer layers of the atmosphere of the star, like the outer regions of the star, get dispersed outward, and they get sent off into the nether regions, and we'll find out what they can do. But this is for smaller to medium-sized stars. Now, bigger stars have a little more interesting fate. They can fuse in the center. They can fuse all the way up to iron. And after that, energy is the energy is hard to come by, because to fuse iron takes more energy than it gives off. So when the core is iron, the star is going to collapse, and what will happen is it collapses with such force that it causes the entire thing to basically pop and to blow up into what is known as a supernova. And a supernova basically is this enormous explosion, and releases huge amounts of energy. And all in this region here around where the explosion happened is you have the birthplace of all the elements heavier than iron. This is elements like copper, like gold, silver, uranium, radon, xenon. There are so many that are made, and so many of these elements are actually necessary for life. So supernovas are actually a huge explosion like the phoenix in mythology, but our life is linked back to supernovas because we have elements in us that were made in a supernova. Now, even the biggest of the biggest stars, when they collapse, there's no force that can counteract this collapse of the core, and it will basically suck itself up into what is known as a black hole. And a black hole is something that basically anything that gets within a certain range of its gravitational field will basically go into it and will go to wherever it goes. But these types of stars will supernova, and at the center of it is the black hole, which is the collapsed core of the star, and it'll supernova and once again give birth to all the elements that are heavier than iron all the way up to uranium, and send these elements hurtling out into the heavens to make other things. I want to go back. One thing I forgot. In these bigger not the biggest of stars, but larger stars, much larger than the sun, like 20 times the mass of the sun, at the center will be left a neutron star, and a neutron star is basically a hunk of matter the size of the Earth that's got the density of a nucleus, and it's extremely dense. It's probably the most dense thing known to humans. Now, one thing that's kind of interesting, as all three of these stars shed their outer layers, they go out into the interstellar material, and one day they could create a new nebula, and that nebula could be the birthplace to a new star. The sun is thought to be a third-generation star, so like is the daughter or the child of two other stars dying.